Hello everyone, welcome to this channel. In this tutorial, we will design an voltage source circuit using LTspice tool. The voltage source circuit consists of potential divider and voltage follower with transistor included at output. A voltage source is designed to provide a constant output voltage. In this design, the load resistance value is 150 ohm and the supply voltage is around 12 volt. We will use BZX84C6VZL Zener Diode, and the breakdown voltage of this particular Zener Diode is around 6.2 volt. Now, based on this particular available data from the data sheet, we will calculate the required resistor and the required current which we need to calculate for this. So you can see this particular calculations for your reference purpose. Based on this calculation, we will design the circuit. Now let us start the design and simulation. So click on components and select opamps. Now search for LM108A opamp and we will select this particular opamp and click OK. Now in order to rotate and mirror the opamp, use Ctrl plus R function or Ctrl plus E function. Once the opamp is placed in the desired way, click Escape. Now we must place a Zener diode. So select Zener diode and use Ctrl plus R in order to rotate this particular diode and place the diode on the schematic window. Now right click on the diode and select Pick New Diode, and for this design we will use the particular resistor from onsemi and click OK. Next, we have to click on resistor and place this particular resistor on the schematic window. Also, place a second resistor which will act as our load resistor. Next, we must place a transistor, and due to a higher load current levels, select the NPN transistor and place this on the schematic window. Right click on NPN transistor and select Pick New Transistor and select 2N2222 transistor, which is required based on our design calculation. Click on capacitor and place this particular compensating capacitor in the schematic window. Now click on wire and connect the Zener diode to the resistor R2 and the resistor R1 to the other end of Zener diode D1. Now connect the resistor R1 to the transistor Q1 and the gate of transistor to the output of opamp, that is LM108, and the emitter of the transistor is connected to the resistor R2. Now connect the capacitor to the terminal 8 of opamp and the other end of capacitor to terminal 1 of opamp. Now we must place a supply voltage source of 12 volt and minus 12 volt. So click on component and select voltage and then place two voltage source and click escape. For this particular voltage source, we must place a ground connection. So click on ground and place this particular ground connection. Now connect the negative terminal of voltage source to ground and the positive and draw a line or a wire on the positive terminal and click escape. Now right click on the wire and select the label net and define this label net as VCC. Click on wire and draw a wire across the negative terminal of LM108 and again draw a wire on the positive terminal of LM108. Now click on label net and define this as VEE. Place this across the negative terminal and also on the negative terminal of supply voltage V2. Again click on label net and define this as VCC and place this particular label net on the positive terminal of the LM108. Now right click on the voltage source V1, define the DC value as 12 volt. Similarly right click on V2 and define the value as minus 12 volt. Now click on wire and connect the terminal 3 of opamp to resistor R1 and the terminal 2 of opamp to resistor R2. Now right click on resistor R1 and define the value as 270 ohm and right click on resistor R2 and define the value as 150 ohm. Now right click on capacitor C1 and define the value as 30 picofarad. Now we must place the supply voltage of 12 volt for this circuit. So click on label net and type VCC and place this on the wire. Now click on ground and place the ground on the schematic window. Join the ground terminal to the circuit. Now in order to perform the transient analysis, click on Spice Analysis and define the stop time as 4 micro and click OK. Place this particular syntax on the schematic window. Now click on run and you can see the simulation and click on the terminal between the emitter and the resistor. You can see the voltage across the load resistance is equal to the Zener Diode voltage. Now in order to determine the operating point of this particular circuit, what we need to do is that go to edit and click on spice directive and here just type .op and place this particular syntax on the schematic. So I have already placed here. Now run this particular simulation. You can see the operating point of this particular circuit. You can see that the voltage which we got during the transient analysis is similar to the voltage with respect to the operating point, and this matches with our theoretical calculations. Thank you for watching this tutorial. I hope this has helped your learning purpose. I request you to like, share and subscribe my channel below.